All right, couple of announcements. Don't forget, get your masks on, but a couple of announcements. One is I don't know if I told you that the person that gets the highest score in my class gets a ninja sword. And a number of you have been in class before, but this is the ninja sword that you will earn if you have the highest total points at the end of the semester. So we'll figure out a way to get it to you if you're a senior. But if you've ever been in Professor Clark's office, he has two of ninja swords that he won when he was a student of mine back in the day. So anyway, just to give you more motivation. The other is that the classic album of the week is Dire Straits. How many have heard anything by Dire Straits? Okay, well, you really should. I mean, Mark Knopfler, one of the greatest guitar players of all time. This was their first album, and Sultans of Swing is probably the best song on here. So you might get on Spotify and look at Sultans of Swing. Again, they did a number of albums, and then he did some on his own. But great guitar player, Mark Knopfler. So Dire Straits, take a listen to that. All right. So we've been looking at externalities, and if you think about it, carbon emissions are not likely to fit the Coase theorem, right? Because what do you need for the Coase theorem to work is you need low transactions costs. So, I mean, even if you're thinking about California deciding to reduce carbon emissions, then how are they going to keep people from Nevada from putting carbon into the atmosphere and it drifting into California, right? So you'd have to run around and try and make trades with everybody, so it clearly can't work. But one of the things that we talked a bit about was a carbon tax, and we said that a carbon tax is a Pigouvian, I mean, it fits the Pigouvian tax model. So if you see somebody proposing a carbon tax, that is not an unusual thing to do. I mean, the problem, of course, is figuring out what the marginal external cost is, right? If you impose a Pigouvian tax, then I got to sort of know what the marginal external cost is. And it's possible I could make the cost, if I made the carbon tax too high, I may end up with lost output that's not being produced when the marginal benefit of that output was really bigger than the marginal cost, including the marginal external cost. And then we said, well, let's take a look at what the optimal amount of abatement would be, so that now we're talking about abating, and we drew a little diagram last time. We're talking about zero emissions. This is the emissions abatement. So we have no abatement here, and then we have 100% abatement over here. So we'd have no emissions at all if we did that. And there's some sort of marginal, if you think about it, there's some sort of marginal benefit to the eliminating emissions, right? Whatever that marginal external cost is, whatever the cost of the pollution is, I'm going to have some sort of marginal social benefit that occurs from the abatement. But let's presume that it has diminishing marginal, this is the marginal social benefit of abating. And you sort of think about it, if the air is really polluted and really hazy and you can't really see through it, then getting rid of some of the pollution might have a really high marginal social benefit. But let's say the air is 99% pure, and now you're trying to make it 100% pure. What's the marginal social benefit of that extra little bit of abatement? It's probably it's probably small. So just as we assume marginal benefits of almost anything, we assume in 202 that they decline, there's some marginal social benefit from abating emissions. But there's also a marginal social cost to abating emissions, right? You got to put scrubbers on. Maybe you have to use a different technology of production that's more expensive. Maybe you have to use different inputs, et cetera. And we would expect that again, you'd have increasing marginal costs of doing that. So if firms are out there when they're just doing a little bit of abating, maybe that doesn't cost very much to put scrubbers on, or maybe it doesn't cost very much to use a different input than the one you're using now. But as you try to get towards a 100% abatement, so there's no pollution at all, we'd expect to see a marginal social cost there. And so there's some sort of optimal amount, we'll call it A star, we'll say that's the optimal abatement. Now, if we knew what the total amount of pollution was, we could then say, okay, here's the amount of pollution that there should be, right? If we say, okay, here's the amount of pollution that if you don't abate at all, here's the amount that's optimal. What we could do is we could set some standard, right? We could set an optimal amount of pollution. And then what you could do is, you sort of think about it, what you could do is you could let people, you could assign it to certain people and let them trade, right? So we're going to get to cap and trade here near the end, or later on today, but the idea of cap and trade might be to say, okay, we've got this optimal amount of pollution that's out there, let's allot it to people. Does a lot have one T? We don't know? One T? Okay, good. So allot it to people, and then we could let them trade. And we will we'll come back to that here as one of the mechanisms that we might deal with pollution. If somehow your government knew what the marginal social benefit was of pollution, right, and they knew what the marginal social cost was, then you could determine, okay, this is the amount of, marginal social benefit of abatements, right? We'd know, okay, this is the optimal amount of abatement, this is how much pollution's out there, let's let people pollute this much, and we'll let people swap it around. You could do that, okay? Again, can you actually do that? Probably not, right? But all we're doing is giving you guidance, right? It's saying, hey, maybe it's not very good to say zero emissions, right? As long as you've got increasing marginal social costs of following up with this abatement, like, it costs a lot of firms, maybe nobody can produce anything, right? Then, hey, maybe we've gone overboard, right? So, but it's just to give you this idea that there's, to say we're going to have zero emissions by a certain day, you must have, if you're doing it correctly, right, you must have thought, okay, I know that the optimal amount of abatement is 100%. So I must have made some decision about what the marginal cost of making that abatement is, and what the marginal benefits to the society is from that. Notice that what happens if you have a system where we say, we're going to allow every firm to put a certain amount of pollution out there, and you can do that, and then you can't go anymore, right? We're going to say there is a regulated amount of pollution. Right? Suppose we do that. So we say, okay, there's a regulated amount of pollution, and we all get to, we say, okay, you can put that much out into the atmosphere and you can't go any beyond that, right? So if what happens is we do that for each firm, right, that's the same for all firms. We've got this general regulation. Well, that's not going to be efficient either. Sort of think about it for a couple of reasons, but one obvious reason is that suppose that you have two firms that they both have the same marginal external cost to us of polluting, okay? So what we're going to do here is we're going to We're going to put dollars there, and we're going to look at what's the optimal amount of, we're going to have some, here's the amount of emissions that you can, the amount of emissions that you can put out. And we say, okay, that's it, right? We'll call that QR. That's the quantity of emissions that everybody can have. You're the Hillsdale BPU can put out so much carbon into the atmosphere, and Consumers Energy can put out so much into the atmosphere, and everybody's got the same amount that they could do. Well, then you got to think through again, what's the benefits and costs? Suppose that the marginal external cost, there's two firms, and suppose that we'll have two firms, and that the marginal external cost of pollution is the same for both of them. So we can draw the marginal external cost. Suppose the marginal external cost looks like that. So the marginal external cost for firm A and firm B is we'll just make it constant just because it's easier picture to see. And so we've got a marginal external cost that's the same as we have the emissions going on. And so let's also assume that there's a marginal benefit to you of emitting, right? Because I don't have to put the smokestack on, or I don't have to put the scrubber on, or I don't have to use this particular input. And so what we'll have is we'll have the marginal benefit. We'll have a marginal benefit here, the firm A, and then what we'll do is we'll have a marginal benefit to firm B there, and that's the marginal benefit of being able to put stuff out into the atmosphere. Okay, so one firm, they can switch inputs easily. They can use natural gas instead, but the other firm, it's really expensive for them to use natural gas. They'd be better off using coal. Coal's got more carbon emissions than natural gas, and so they gain more from it. Well, if we were to do it, the optimal way would be to say, okay, this is the amount of emissions. That should be the quantity of emissions that firm B should have, and this is the amount of emissions that firm A should have. They should go and be able to emit as long as the benefit to them of being able to emit, that marginal benefit, is greater than the marginal external cost that they're putting on the rest of us. So if we have a regulation that says, okay, here's the deal, firms can produce so much emissions, and then after that, we send them to jail, right? We do something and they can't go beyond that. Well, if we do that, then what's going to happen is at QR, what's going to happen is firm A is going to produce that amount of emissions, and firm B is going to produce that amount of emissions. And if they all are the same, then what's going to happen is that the marginal, the amount of emissions, the emissions of firm A are too big, right? They're greater than, so they're greater than the point where marginal benefit equals marginal external cost. And with that, so firm is, the A is going to produce too much, right? So for efficiency standpoint, firm A produces too much, and B produces too little, because B's got to produce the same amount as A, right? And if B's got to produce the same amount of A, what's going on? The marginal benefit to B of being able to make those amount of emissions is bigger than the marginal external cost. So a common regulation, which is oftentimes you see that there says, okay, here's how much you can emit, and beyond that, that's illegal, Okay? That is an inefficient way to do that if you have a variance in the benefits. Now notice that if you had a Pigouvian tax, right, if you knew what the Pigouvian tax is, a Pigouvian tax, it would work here, right? Because if what I did was you had to pay the marginal external cost, which is what the Pigouvian tax would be, B would go to here, where the marginal benefit to them is equal to the marginal external cost, which is the Pigouvian tax they're having to pay, and A would go to here, and so you'd get the right amount. So if it's possible I mean, what we're saying is that a Pigouvian tax would be more efficient than doing a common regulation. Again, even though we know that's the case, what's probably going to happen in public policy? What's probably going to happen is that it's easier public policy-wise to make the emissions the same for everybody. Then I don't have to deal with maybe some people say, well, this company had a better lobbyist, and so they got more, they could emit more than the other company. Okay, so you're not likely to get to the right spot. But again, if it's obvious, like we said, when you're looking at US 12 and Milnes in terms of who should have the property right to cross the road, if there's some sort of obvious situation, it moves you in the right direction. Another way of, or another point to make is that suppose that you have a common regulation, but there's a difference in the externality rather than the marginal benefit. Suppose that you have a common regulation, but you have two firms, one of which is in LA and one of which is in Wyoming. So if we were to draw something like that, and suppose that these firms have identical benefits from being able to pollute, right? So suppose that you have two firms, A and B, and they have the same marginal benefit of polluting. But suppose that one's in LA, the marginal external cost of pollution is high, right? Because, well, LA's got this, it's a basin where air tends to get trapped there. And what you have lots and lots of people. We were saying that, there's more externalities when you have, lots of people rather than a small town. If you're out in Wyoming and you're putting something into the atmosphere, then there might not be very many people out there to have the marginal external cost on it. So we'd have in Wyoming, you have the marginal external cost is low. Well, if we do that, what we're doing is we're assuming the marginal social benefit for A, and we'll call those firms A and B, the marginal social benefit's equal to the marginal social benefit from B, which the marginal social benefit is really the benefit to that firm, right, from being able to pollute, right? This is the benefits to the firms from being able to pollute. And again, declining marginal benefit here. But suppose that the marginal social cost in LA is up there and the marginal social cost in Wyoming is here. Well, if we put dollars here and we put pollution here or emissions here, then what ought to happen is that the firms in LA, we'll put that QLA, the firms in LA ought to be limited to their pollution more than the firms in Wyoming. So there ought to be a different standard in LA than Wyoming. Again, can we figure out what the exact amount of that is? And the answer is probably not. But we got some intuition that says, you know what? If you're a firm in LA, you shouldn't be able to pollute as much as the firm in Wyoming, right? So just at least by doing this analysis, we can move you in the correct direction. Can we, figure out exactly what the marginal social cost is of, another ton of carbon dioxide going out there? Probably not. But at least it gives us a method of going through and your public policy and going through and saying, hey, a common regulation across all firms probably isn't going to work. Okay? If we know that it's really expensive to reduce emissions with this type of firm, then maybe they ought to have a higher amount of allotment to the emissions. And if we ought to have firms in LA have a smaller allotment than firms that are in Wyoming. Again, if we had a Pigouvian tax, then you'd be okay, right? If you had a Pigouvian tax, what would happen is that the Pigouvian tax for firms in LA would be up here, right? And the Pigouvian tax for firms in Wyoming would be down here, and you'd be okay. So if you had some mechanism where you had an idea what the costs are of this pollution to people, you're probably better off saying, okay, let's have a carbon tax, or let's have a tax on whatever the pollution is, and we'll let that we'll have a different tax depending on where you are. Now, again, what if you if you figured out what was the optimal amount of pollution that could go out there? So you go back to where we were talking about if we could somehow measure the marginal social cost of emissions, and we could measure the marginal social cost of the marginal cost to the firms, and we were talking about earlier, the marginal cost to the firms of reducing their emissions, and what's the marginal social cost they're putting on us, right? So we could figure out what the marginal social benefit of emissions abatement is. That ought to tell us if we know how much pollution is going on right now, whatever is, let's say we ended up with a 50% abatement, then we'd say, okay, you got 50% of the emissions is the allotment that we got that we're going to hand out to people to be able to emit. So that's what's called a cap and trade. You've probably heard some discussion about that. So what a cap and trade program does is it says, okay, here's the allotment of emissions that we of the government have determined is the proper amount, or at least the close to the proper amount as we're going to get, right? So what happens is government sets an allotment for emissions. All right, so the government sets an allotment for emissions. And then it says, okay, what we're going to do is we're going to assign that allotment, right? We could do it where some firms get a big amount, some firms get a little amount, or we could do it where everybody gets the same amount, or we could just say, here is a pile of allotment of emissions. Here's how many emissions can come out there, and you can buy them. Okay? So in a cap and trade, what happens is you give firms some amount of the allotment, and then they can trade them. So if you're the firm where the marginal cost to you of reducing your emissions is really low, and the marginal cost to me of reducing my emissions is really high, then what can happen is you can sell me your allotment of emissions, or you can sell me a portion of it, right? So the idea is that you've got some standard, right? So there's some cap, right? That's the cap. We say we're going to allow so many tons of emissions of sulfur dioxide into the atmosphere in the United States, and then what we're going to do is we're going to give the allotment out to people, to different firms, and then what we're going to do is we're going to let you swap them. And indeed, we have such a thing. It's for sulfur dioxide. That program has been around for about 30 years, almost 30 years. Sulfur dioxide emissions have this very characteristic to them. There was the 1990 Clean Air Act. Oops. The 1990 Clean Air Act, it set an amount of emissions for the sulfur dioxide. And then what happened, so the Clean Air Act actually gave it to EPA. Oops. EPA could set how much SO2 can be emitted. Okay? And then what happened was in 1991, the Chicago Board of Trade set up a market for these rights. Okay, so we have the 1990 Clean Air Act comes about. The Clean Air Act says, you know what, the EPA can set a standard for sulfur dioxide emissions, and we can allot them to the different firms, but now you can trade them. So in 1991, the Chicago Board of Trade, they set up a market for this. So you could buy and sell, the Chicago Board of Trade, you can buy and sell emissions. So if you're a firm in LA and you want more emissions and somebody else is a firm in Wyoming, then the Chicago Board of Trade matches them up, right? So there's a market for it. Just like if you want to buy a GameStop stock, you can go to Schwab, and there's a market set up for you to buy GameStop stock from somebody that doesn't want the GameStop stock. Which we're going to look back 30 years from now and go, what the heck was he talking about? So anyway, but you can see that the Chicago Board of Trade set up this market. So if I'm, like I said, if I'm a firm in LA and it's valuable for me to have this allotment and you're in Wyoming and it's not that valuable to you, then we have a mechanism where we can trade that around. There's a nitrogen oxide trading program. Oops, nitrogen oxide. There's also a trading program in nitrogen oxide, and that was set up in 2003. And there was another program that took it over. It's about 2010. It was replaced with another program, but basically there is a program dealing with nitrogen oxide. Yeah.
Isn't it safe to assume that the EPA would allow for fewer emissions than just a pure market decision would? So by doing this, firms are already restricted in how much they can emit from the start?
Like does the EPA have an incentive to have a very small amount of emissions? Is that what you're asking? Well, all you got to do is listen to the president, this president versus the prior president, right? Some presidents are more concerned with emissions than others are. And what is that going to be about? It's going to be about whether you folks have thought through, is zero emissions a grand idea, right? It's possible, okay? But zero emissions is that, if you're looking at what's the marginal social benefit of reducing emissions to zero rather than a 80% reduction by a certain date. So if you're making such decisions, all that we're saying here is these are the things you should be considering when you do that. From a public choice perspective, if you folks are rationally ignorant and you're going, hey, I think it would be great if we just had clean air, and you know the carbon dioxide going into the atmosphere is causing global warming, and global warming is going to be bad for all of us. Let's get rid of carbon dioxide emissions. Okay, if that's as far as you get in your thought process, then if I'm in a legislative arena, or if I am running for president, then I'm going to support zero emissions, okay? Unlikely that when I am running for office, I'm going to draw those diagrams that we just had here, right? I mean, how often are you going to have a press conference and President Biden is over here saying, okay, here's the marginal social benefit from doing this, and here's the marginal social cost, and we're going to set the emission standard not at zero, but we're going to set it to where the marginal social cost is equal to the marginal social benefit. Okay? Could happen, but you're right. That is, and what we're trying to point out here is, let's at least know when we're wrong, or let's at least know what direction we ought to be moving in. And it is quite possible that there is a marginal external cost to carbon dioxide in the atmosphere. That's quite possible. Somehow we might try to get a measure of it. And what we need to do is, again, since costs can't hold, you know, the transaction costs are too high, then what's going to happen is there's going to be a carbon tax probably makes some sense. Okay. Now, if you look in your folder, in the 402 folder, in the section on externalities, I've got a couple articles in there about carbon taxes and cap and trade and things like that. So again, if you want to develop your idea for a paper, or if you're just more interested in that, you can take a look at these further discussions. All right. In California actually has a cap and trade on emissions that started in 2006. So now you have some states that are putting emission standards. And then, of course, there's a question, there was a lawsuit about it, but the question is, can states do that? And then you might think, well, what sort of states might do that, would have a carbon emissions standard? And if you were thinking about it, California probably makes some sense to do it because the states around them aren't likely to have a lot of carbon emissions coming out of it, right? If you're looking at Nevada and you're looking at Arizona, maybe you're looking at Oregon, there might not be a lot of stuff drifting in from those other places into California. And so maybe it makes sense for California to have a carbon emissions or a carbon tax or a cap and trade or whatever. Maybe it makes sense for them. Whereas if you are in New York State, maybe that wouldn't make so much sense. Maybe because New Jersey would be doing things and they'd be producing emissions that would be drifting into New York, et cetera. And of course, when you look at emissions obviously move across borders, and that's one of the problems. Like, what if the United States undertakes this reduction in carbon emissions and absorbs the cost of that through higher input prices, et cetera, and a higher cost of technology to produce things, and then somebody else, like China right now, has been selling lots of coal and loaning money to developing countries for electricity for coal-fired power plants. Okay? So if what happened is if the carbon dioxide that's going up in the air is causing global warming, whether it's in sub-Saharan Africa or whether it's in the United States, well then that's something that you also have to think through. All right, let's just a couple other comments. One way to think about it is also, what if you find a way to remove the carbon? What if there's a way that rather than undertaking the cost of abatement, right, making it so the firms don't emit, what happens if you found a way to take the carbon out of the atmosphere, and that way was inexpensive, right? In fact, if you think about it, we'll talk a moment about public goods, but if you think about it a moment, you know, you've talked about common property resources probably in other classes. If you have a common property resource, which would be carbon, and there was some way that you could take the carbon out of the atmosphere and use it to produce something, right? Maybe what would happen is we'd start running out of carbon because we're all trying to get the carbon in order to produce whatever we're producing. That's probably a little extreme, but just some comments here. There is an X Prize. There's an X Prize out there, which is a prize that has been offered. If you get on the website, there's a bunch of different X Prizes, but there's an X Prize. I believe this one is called. The X Prize is called NRGCOSIA. These are two companies, I guess, that are have given money to it. But what it is a contest, and it awards a $20 million prize. And that $20 million prize is how much based on how much carbon you take out, and the value of what you produce with it. And there are, if you get on their website, you'll see that there are 10 firms that are in the finals for the prize. And you know, one of the things that one of the firms has done is figured out a way to take carbon out of the atmosphere and use it in the production of cement somehow. Somehow you can use this carbon in the production of cement. Anyway, there's 10 finalists in this. But the point then being that this is another way to think about it, right? Maybe it's more efficient if you've got stuff going off into the atmosphere. Then you don't have to worry about if China is producing carbon dioxide or sub-Saharan Africa is producing carbon dioxide and it drifts into the United States, or somehow it does. If I can suck that carbon out of the atmosphere, then I don't have to worry about it moving across borders or whatever, because maybe I want to be able to get that carbon. So that's just an interesting thing to think about. Another point of externalities is if you look at zoning laws. Anybody know where the first zoning laws came about? First zoning laws came about in New York City, and it had to do with skyscrapers. That is, you know, if you build this whole skyscraper, then what you do, you block out the light of these, you know, the houses and other smaller buildings around you. That's where this started. But what are zoning laws about? Zoning laws are about an externality, and in general, if we think of it as a negative externality, and says, okay, you can't do that, right? So if you might have a zoning law in in the city of Hillsdale that says that you can't put maybe you can't put a 7-Eleven in some neighborhood, right? There might be some sort of, I don't know exactly what the law is, I'm just making this up, but you can think of a thing where you can't put a manufacturing plant in a neighborhood, okay? Why is that? Because of this negative externality that would be there. Everybody in the neighborhood would have all this noise, and there'd be people driving in and out, and trucks driving in and out, et cetera. So the zoning laws, what are they about, right? They're there to deal with negative externalities. That's the one mechanism to do that. Just say we're going to prohibit that. You also have a blight regulations. And what I mean by that is most places have it where you can't just let your building run down. Okay? If your building runs down to a certain extent, what will happen is there'll be a city official or a county official, probably a city official, and that'll come around and say, oh no, you can't, you got to fix this up. Or there's a few houses that you can see in Hillsdale that have a yellow sign on them saying they're not habitable. Okay? And then there's different mechanisms to try to deal with that. But there are, and it depends on the state, how those regulations work. Can they seize your building and make you, pay it, pay to have it destroyed? If, let's say, it gets so far that it can't be fixed, could you have the city, seize the property and knock it down and charge you for how much it costs to knock it down? Right? You can have all sorts of laws depending on what state you're in, but there you can see that you have those laws. And what are laws dealing with that, where houses are condemned or something like that? They are oftentimes to deal with negative externalities. And of course, there's questions about what should the law look like as well, right? Can I just stop paying my property taxes on a piece of property, and then at some point the property gets turned over to the city, but now the city's got this beat up piece of property that they got to pay $30,000 to tear down. How do you deal with that? So that's a question that's out there, and I know that the state of Michigan has been dealing with a little bit, is how do you deal with such things? But anyway, this is basically a negative externality situation where if my house is on 640 acres and sitting in the middle there, nobody's going to come along and make me tear it down, or if I let it fall apart, nobody's come along and do something, because there's zero negative externality there, because there's nobody to, as Coase pointed out, there's no one to have the externality there. Another one is, this is on a sort of a positive externality. I have a paper that I published a number of years ago on the sale of development rights. And it's to preserve open space. People may want to have, they get a positive externality from being able to look out over this open space, right? And they don't want to have if somebody put a gas station there, okay? Now, one way that you could do that is, let's say you wanted to, you could buy the property, and in order to get it away from the person that there was a farmer that wanted to put, or let's say not a farmer, but let's say there's some vacant land in your neighborhood, and there's some vacant land in your neighborhood, and the owner was thinking about selling it to a gas station, and you like looking out at the open space. You could buy the property from them, right? But maybe you could just buy the development rights from them, right? You could separate out ownership of the property from what are the different things that you can do with that property, right? So if you can separate out the property rights, I'm just buying the right to develop from you. You still own the property, but I'm buying the right to develop it. Okay? So that's one mechanism where you could do with a positive externality, or you could prevent a negative externality from coming in by, again, you could internalize it by buying up the whole property, but maybe I just want to buy up the right to develop it. Yeah.
Would you go to the other property owner to buy that, or are those determined by the government?
Well, you'd have to have a statute that allows you to do that, right? What my paper was about was that we ought to allow for the sale of development rights in Michigan. So it would depend on the state how they, whether they allow you to separate the different property rights from the, and remember we talked about pollution as, or excuse me, externalities as really a property rights issue, right? Who's got the right? And so if you, how much can I separate out those different property rights? And again, it depends on the state, how they're going to allocate that. And a last thing is private association rules. Sometimes you have neighborhood associations. Some states allow for neighborhood associations. So you have private associations. So let's say you have an area where, in fact, where the neighborhood where my house is there is, and when you bought that piece of property, it says on the property that you have to follow these association rules, which says that you can't do this, you can't do that. So what you could when you're let's say you're you're going to start a subdivision, okay? And so you buy up this piece of property, then you start the subdivision. Well, you might have as part of the title in the subdivision, if you buy property in that subdivision, it says you can't put a gas station in here, right? Or you can't do this, or you can't do that, right? So a way of dealing with the externalities might be that you have basically, when we were talking about there's common laws in the sense where we know you don't mow your lawn at 6 o'clock in the morning on Saturday, okay? You might have a more formal way of addressing that in a homeowners association. Or there are also, if you buy into a condominium, you might buy into a condominium area, there might be rules in the condominium that are meant to minimize the possible negative externalities. All right, so let me just, what we'll do for next time is talk about public goods, and let me just give you one insight about where we're headed. So the next chapter is in public goods is what it's about. It's about a particular type of good, and we've talked about this a little bit before, is a public good has three characteristics. One, it's non-rival in consumption. We already talked, and we've talked about this briefly before. It's non-rival in consumption. That is, my consumption of it doesn't affect your consumption. My viewing the fireworks doesn't make the fireworks go down a little bit for you. The second thing that we said was that they're difficult to exclude. And if you thought about it, if they're non-rival in consumption, then you really wouldn't want to exclude somebody because they could have the use of the product or whatever it is, and it doesn't reduce the amount that's left over for you. So if you were at a point where you're excluding somebody, you could make somebody better off without making somebody else worse off. And the third thing is you all get the same amount. Right? In a private good, you can choose to have different amounts of cups of coffee, or you can choose to have different amounts of McDonald's hamburgers, and you face the same price and you make that decision. But in a public good, we all get the same amount of fireworks, we all get the same amount of national defense. So what we'll do for next time is we will start the chapter on public goods. So we've finished we finished through the externality chapter, so I'll start the chapter on public goods.